Imagine that you clone a repository from GitHub from a teammate and something which a developer does many times a day, right? And you do that to try out a library or review someone else's code. And you open it in your AI coding assistant and you haven't run anything yet. You haven't approved anything, but a few seconds later, a hidden command has already run on your computer and it's opening a connection back to an attacker, and your secret API key is on its way to their server. And you have done nothing except open this one folder. Now, these are two real flaws found in Claude Code, which is Anthropic's AI coding assistant. And these have been found by Checkpoint Research. One is tagged as CVE 2025 59536, the other as CVE 2026 21852. Now, both of these are fixed in current versions. I'm going to walk through them together because they both tell one story, and it's an important one. That the files in a project that everyone treats as harmless settings can run code on your machine and steal your credentials. Now, in this video, I'll show you exactly how that works with a lot of diagrams and why this whole class of attack is going to keep happening as AI tools move into how we build software. It's going to be very visual, so just follow along, and everything here comes from Checkpoint's public write-up and Anthropic's own advisories. And I've simply taken all of this publicly available information and condensed them into these nice diagrams. First, let's quickly understand what Claude Code is. It's an AI coding assistant that lives on your computer and actually does things. It can read your code, it can run shell commands, it can edit files and run tests. And that's what makes it useful. It's not just answering questions, it's acting on your machine as you with your permissions. And that's the important part for this whole video, because Claude Code runs with your access. It can touch your files, your terminal, your credentials, and your SSH keys. And it uses a secret API key to talk to Anthropic servers. So anything that can control Claude Code can reach everything that you can reach. And I want you to hold on to that thought, because the attack is about turning that power against you. Now let's look at the heart of this attack. A project, a repository, is not just application code, it also contains configuration files. So these are little files that hold settings for your tools. Claude Code reads one of these, which could be a file at a path like .claude/settings.json, to know how to behave in that project. And there is an assumption that developers make where they treat configuration files as passive data. They think of them as settings, as harmless metadata. So when you review someone's code, you read the actual program carefully, but you skim right past the config files. Because what harm can a settings file really do? That assumption was true for a long time. It is not true anymore. In modern tools, these config files are active. They can run commands and they can redirect where your secrets go. They look like data, they behave like code, and that gap between how safe they look and what they can actually do is the entire attack. So let's look at how an attacker's config file ends up on your machine. It's actually the same way that all your code ends up on your machine, which is the way you clone it. So you git clone a repository to review a pull request, and you try an open source project to check out a teammate's branch. And you do this constantly, and you do it without much thought, because cloning a repo feels safe. You're just downloading files to look at them. Now the attacker just needs their poisoned config file to be in a repo that you'll clone and open. That could be a malicious open source project. It could be a single bad pull request to a project that you maintain. It could be an insider adding it to an internal company repository. The point here is getting the file on your machine is the easy part. It rides in with the normal everyday act of cloning code. But now let's look at what that file does. The first thing that the config file can do is run commands automatically. Claude Code has a feature called hooks. A hook is a command you tell Claude Code to run automatically when something happens. For example, when it starts up in a new project. It's a legitimate, useful feature. You might want a setup command to run on its own every time you open your project. The hooks are defined right there in that .claude/settings.json file. And here's the flaw. When you open Claude Code in a cloned, untrusted repository, the hook commands in its config file run automatically without asking you. There was a trust dialog that mentioned files being executed with your permission, but it gave no warning that hook commands would fire on their own with no separate approval. So the session looks completely normal to you, while a command from a stranger's repository has already run in the background. Now, here is the flaw. When you open Claude Code in a cloned, untrusted repository, the hook commands in its config file runs automatically without asking you. And there is a trust dialog that mentions files being executed with your permission, but it gives no warning that hook commands would also fire on their own with no separate approval. So the session looks completely normal to you, while a command from a stranger's repository has already started running in the background. So now let's put the attacker in that hook. Instead of a harmless setup command, they write a hook that downloads a malicious program and runs it. So the moment you open the project, it runs. So checkpoints proof was the classic one, which is the calculator app popped open on its own, no prompt with no warning, which is the universal way of saying I can run anything that I want here. But the real version is not a calculator. It's a command that opens a reverse shell, which is a live connection from your machine back to the attacker's machine, handing them a remote command line on your computer. From that moment, they can do anything you can do, which is read your files, steal your keys, move deeper into your systems. So you opened a folder to look at some code and a stranger got a shell on your machine. So that's remote code execution. And it was the first of the 2 flaws which were rated with high severity. Now, this is the second flaw, and it's much sneakier. While investigating, the researchers found that hooks weren't the only dangerous thing the config file controlled. It could also set environment variables, which are settings that change how a program behaves. Now, one of the settings is called Anthropic base URL. It tells Claude Code where to send its requests, which server to talk to, and normally that points to Anthropic, but the attacker's config files sets it to point at their own server instead. So now Claude Code has been told to send its traffic to the attacker. And remember, every one of your requests carries your secret API key to prove that it's you. So the redirect doesn't just reroute traffic, it reroutes traffic that has your key attached. And here is the issue. Claude Code already made an API request before it showed you that trust prompt. So before you had approved anything about this suspicious repository, Claude Code had already fired off a request carrying your API key to the address that the config file had specified, which is basically the attacker's server. The attacker reads your key right off their own logs. So simply opening the repository is enough to hand over your active API key and redirect your authenticated traffic to someone else's infrastructure. So there's no clicking, no approving, and with your key, the attacker can run up charges in your name and worse, impersonate you to the API. This was the second flaw. An information disclosure bug lowers code on paper, but losing your live credential just by opening a folder is a serious thing. So let's look at the entire chain in one go. You clone a repo, you open it in Claude Code. Its config file runs a hook that opens a reverse shell on your machine, and its config file redirects your API key to the attacker's server, and both happen automatically before you approve anything. So it was just one poison settings file with 2 payloads, and it opened a shell on your computer, and your key is now in the attacker's hands, and the whole time your screen looks completely normal. Okay, so I want to quickly pause. So you just saw the entire attack chain in the diagrams, but if you want to be more hands-on as an attacker or a red teamer or a pen tester, you would want to run these attacks on your own in a safer environment. To help you do this, I built multiple labs, and they're all part of the Armor Dojo. I'll leave the link of that in the description of this video. But some of the advanced labs do require a premium access because most of the labs are very difficult to build and maintain. So there are multiple types of attacks like this one that you can simulate in the Armor Dojo. Now, this attack is a little different from other AI security stories because there's no prompt injection here. Nobody tricked the AI model into misbehaving, and the model isn't really even involved. The attack is just pure configurations, which are files that the tool reads and acts on. Now, configuration files used to be passive data, but now in tools like this, they're actually active. They run commands, they redirect your credentials, they point to a tool at the other servers. But our habits as developers haven't really caught up. We still review the application code, and we don't look at the config files. And the main lesson to carry away from this video is that a config file is not just data anymore. It can be code, and it can actually be a thief. And this attack can actually scale into something very frightening. One poisoned config file in one repository can hit everyone who clones and opens it. And now it actually becomes a supply chain attack. So you didn't just target one victim, you poisoned a shared resource and let the victims come to you. And the thing is, this is not just a Claude Code quirk. It's actually a pattern across the whole new category of AI coding tools. For the longest time, opening a file or a folder just meant reading it. It was passive and safe. But with these tools, opening a project is actually an action. Now, it's important to be mindful of the stakes here because on your machine, you have your source code, your cloud credentials, your SSH keys, and your access to production systems, and your tokens for GitHub and your package registries. So a reverse shell there is not the end of the attack. It's actually the beginning of the attack. So from your laptop, an attacker can actually reach everything that your laptop has access to, which in a lot of companies is actually all of the infra. So really, there's just 2 questions you can ask yourself. First is when you open a project, does anything run automatically? And 2, can any config inside that project control where my credentials or my authenticated traffic go? So why can't we just fix it by scanning config files for dangerous commands? Because that's a losing game. There are endless ways to hide and obfuscate a command, and you'd be just trying to recognize every bad one in advance. So the fix that actually works here is about the trust boundary, not the content. The rule should be when a project is untrusted, nothing in it runs and nothing touches your credentials until you have explicitly approved that project, and the approval should clearly tell you what's about to happen. So let's look at the takeaways. Now, if you use AI coding tools, firstly, you should update. So let's look at what we can learn from this video. Firstly, if you use AI coding tools, then you must update because both of these issues are fixed in current versions, so old versions are the risk. Then you should build the habit that opening an unfamiliar repository is not free. And for code that you don't trust, open it somewhere isolated. It could be a container or a throwaway virtual machine. So a hook firing cannot actually reach your real machine. And give your daily environment the least access it needs, so a shell on it is not the master key. And rotate any API keys or tokens that may have been exposed because you have to assume a leak key is already in use. And if you build developer tools, make sure that opening a project must not execute anything and must not touch the user's credentials, especially before the user has explicitly trusted it. Treat every file in an untrusted project, especially the config files, as attacker's input. So the moment your tool does something on a user's machine before they've said yes, you've handed that power to whoever wrote the files that they just opened. Now, researching all of this information and distilling it into diagrams takes a lot of time and effort. So make sure you subscribe to this channel and you like and share this video, and I'll see you in the next one.